Now that we've seen what makes a shape a polygon or not, and just as a quick review, a polygon is just a shape that's made out of straight line segments, and basically it needs to be an enclosed shape. So something like this is a polygon made of just line segments, and it closes up on itself, no dangling ends. This here is also a polygon, assuming that that's straight. It's just all straight line segments and it closes. An example of something that's not a polygon is something like that. It doesn't close on itself, or maybe something like this, where there's a round part, not just made out of line segments. Let's start talking, now that we know what a polygon looks like, about the different parts of a polygon. So we've got what's called the vertex, and we've seen vertexes before, or vertices, before in angles. In an angle, the vertex was just that point right there where the two lines meet. Well, in a polygon, it doesn't change at all, but instead of having just one vertex, I have one for each set of line segments. So I have a vertex here, this right here is also a vertex, this right here is also a vertex, and this right here is also a vertex. So maybe I have A, B, C, and D. All of these things are vertices. Next thing that we need to talk about when we're talking about polygons is the idea of a diagonal. A diagonal is a segment from vertex to vertex, but these vertexes cannot be adjacent. They cannot be next to each other. So, an example here is that A and B are next to each other. A and D are adjacent. They're next to each other. But A and C are not adjacent. So I can make a diagonal, which is just a straight line between these two vertices. Similarly, the other diagonal in this shape, in this polygon, is between B and D, because B and D are not adjacent. Next, let's talk about how to name polygons. So I have polygon A, B, C, D here. So I can call this polygon A, B, C, D. You name polygons the exact same way that you name angles. You take the points that make up your figure, and as long as when I say those out in the order that you give me for the name, as long as that draws the exact same polygon that we're talking about, then that's an okay way to name my polygon. So one name for this polygon is A, B, C, D. Another good way to name this polygon could be maybe A, D, C, B. As long as I draw out that polygon in the order that I say the vertices that make it up, then it's an okay name. I could even start with C and then maybe go clockwise. So C, D, A, B. C, D, A, B. How many different names do you think there's going to be for this polygon? And then a better question after that is going to be, do you think the number of names are going to change based on the number of vertices that our polygon has? Now, when we're naming polygons, the only thing that's not okay in a name is if I say two vertices that are diagonal from each other in a row. So if I said something like A, C, B, D, now if I followed these lines, I go from A to C to B to D. If I put these points in about the same location as before, A, D, C, B, and I followed this orange title, I go A to C to B to D, well, I'm not drawing the same polygon that I had here. So this is not an okay name for this polygon. To name a polygon, you just take a point and you draw out that same polygon. So you can either take any point and then just go clockwise or counterclockwise. The final thing that we need to talk about, not quite the final thing, all right? There's a couple more things. So the next thing that we need to talk about with polygons is naming polygons by the number of sides. So maybe not naming, I should say types of polygons based on number of sides. A polygon, it just has the word poly in front of it. Poly means many. Well, if I want to say a polygon that has only 3 sides, which would look something like this, it's going to look like a triangle. 1, 2, 3 sides. Well, I know I can call this a triangle. I can also call it a threegon. So when I'm giving names to the different types of my polygons, I can just say the number of sides followed by a dash and then gon. So if I had a shape like this, 1, 2, 3, 4, 5 sides, this is a polygon. It has only straight sides. They only hit 2 other sides each, 2 other line segments each, and they only intersect at endpoints. This is a polygon, and because it has 1, 2, 3, 4, 5 sides, I can call it a fivegon. Now, there are different names for different things. A fivegon might be a pentagon, if I draw it like this, or maybe a sixgon could be a hexagon, which is a familiar shape to us. But these are special versions of polygons. This hexagon is just a regular sixgon, except it looks a little bit special. Now, a couple more things. We have to learn the words concave and convex. Concave and convex. The way I like to think of this, these are both types of polygons. The way I like to think of this, though, is that a concave polygon has some sort of cave in it. So if I had something like this, let me extend that line a little bit. It is a polygon. They intersect only at endpoints. Each line hits only 2 other lines, and they're line segments. But right here, if it was raining, I could go under this block right here, and I wouldn't get hit by it. I'm hanging out in this cave. A convex polygon is just the opposite. There are no caves in a convex polygon. So if I have something like this, there's no vertex that is closer to the center than a line between any 2 other vertices. Where in this case, there is, and that's what's making my cave. If there's no cave, though, if it doesn't go inside on itself a little bit, that means that it is convex. If it goes inside on itself and it makes some sort of cave, some place that's inside the shape kind of, then we call it concave. Finally, and this is actually finally, we have what's called regular polygons. A regular polygon is defined as a polygon whose sides are all equal and all of the angles are equal. So all sides are equal to each other, and all angles are equal. If a polygon is not regular, if maybe some sides are different or some angles are different, then we call it an irregular polygon. That means that it's just not regular. An irregular polygon literally just means that it is not regular. An example of a regular polygon would be maybe a square, where every angle in a square is a right angle, and every side length is equal. So that's what I'm putting these hash marks here for. A square is a regular polygon. On top of that, an equilateral triangle is also a regular polygon. I know this is not a perfect equilateral triangle, but all side lengths are equal and all angles inside of it are equal. So this is regular. An irregular polygon is much easier to come up with. I just need to make something that is a polygon, and more likely than not, it's going to be irregular. So for example, if I have something like this, well, these sides are not all equal. These angles are definitely not all equal on the inside, so that means that it is an irregular polygon. The last thing that we really need to be careful about is that just because all the angles in a polygon are equal, or maybe just because all the sides are equal, does not mean that it's regular. So, for example, in a rectangle, all of the angles are right angles. But it's irregular because these two longer sides are only equal to each other, and these two shorter sides are only equal to each other. But to be regular, every single side, all sides must be equal to each other. And I can't say that this top one and this left one are equal to each other. So that means a rectangle, even though it has all equal angles, is not regular. Similarly, I could come up with something maybe like this, where I have a bunch of sides going this way, and if I tell you that all these sides are equal, you might be tempted to say, oh, this is a regular polygon. But these angles are definitely not all equal to each other on the inside. So that means that it is irregular because all angles must be equal.